I am here with Knox Anderson, who is with Sysdig, and he is going to give a demo of Sysdig Secure. And Sysdig Secure is is a new service from Sysdig, and it encompasses runtime monitoring and forensics for containers and microservices. Isn't that right, Knox?
Yep, runtime, security, and forensics.
Excellent. So let's go right into the demo and just get started and see what this is all about. Sound good?
All right, awesome. Thank you. So we're Sysdig. We're the container intelligence company, and we're going to give you unified monitoring, security, and forensics capabilities from a single instrumentation point. So one agent, full visibility into your metrics, your commands, your captures, events history, basically every single thing that's happening on your host. So what I like to always start off with is this topology map of all the security events that have happened in my system. So I can see every single host that's running, and then drill down into those hosts, see all my ingress and egress services, and then go in, see the containers that are running there, which ones have had policy violations, and then all the other processes that are connected between those different containers. But if you're using something like Kubernetes or Mesos or ECS, making sense of your infrastructure from a physical view can get pretty messy. So we're going to integrate with all your orchestration tools as well. And I can change this map and now look at my service from a logical perspective. So now I'm looking at all my different namespaces. I can drill into this Java namespace, see the different deployments, which ones have had policy violations, and then go down into any deployment and see the pods and the containers that are running inside them.
Okay.
Quick overview to see everything that's happening there, and then the next thing that I'd like to go through is kind of an incident response workflow and some of the things that customers are typically doing in these containerized environments.
Okay. So what are we seeing here kind of in the UI? We're seeing, you can look at you can see the entire infrastructure. Can you tell us about kind of your thinking behind the UI that you've developed and how it speaks to the information architecture behind this platform?
Yeah, so this is fully customizable here, and one of the nice things is it shares a lot of the same UI with Sysdig Monitor as well. And we really want you to be able to slice and dice your infrastructure however you want. So right now we're looking at my different namespaces, the deployments. I can go into a deployment, see the pod, and then the container running in that pod. But if you want to dynamically change this however you want, you can switch to a grouping to show your container images, which one of those have had violations, and really customize this to look at your environment in whichever way you see fit.
Okay. So tell me more about what is the technical architecture behind what you've developed here?
Yeah, so we have a agent that's running as a container or a process on the host, and that's going to allow us to install a unique kernel instrumentation that's fully open source, part of all of our products, and that's going to allow us to see every single system call from every container in your environment. And so start automatically detecting app metrics, system metrics, user commands, and enforce policies based on file access, process activity, user activity, pretty much anything that makes a system call, which is basically everything.
Okay, great. So tell us a little bit more about Sysdig itself.
Yeah, so we've been around for about 4.5 years now. We started off as a general Linux open source troubleshooting tool. That's got millions of users. It was created by our founder, Lord Sejuani, who's also the co-architect behind a really popular network troubleshooting tool called Wireshark.
Mm-hmm.
And then on top of that core technology, we built Sysdig Monitor. That's been out on the market for a couple of years now. We're managing and monitoring millions of containers. And then about a month and a half ago, we launched Sysdig Secure.
So Sysdig Secure combines both the monitoring and the security. How is that different? How does that differentiate from what we're seeing out in the market right now?
Yeah, so really on the service level and the ability to understand logical services that are managed by Kubernetes or Mesos, Docker EE, anything like that. Pretty much everything else on the market is doing enforcement and detection based on container images. So if you've got an image like Redis that's running as part of your data processing service and your billing service, you can't differentiate between the two. But since we understand how those services are architected, you can enforce and detect policy violations on those services independently of each other rather than just looking at the image. Then on the forensic side, since we have that core kernel instrumentation, we're able to capture every single system call and every piece of activity pre and post policy violation to see down to every file written, the contents of that file, and give you full scoping of what led up to attack, what happened during an attack, and then the cascading effects afterwards.
So the services, so you talked about how the services are architected, and then you talked about the forensics and the granularity you can provide that, through your, it's really, is it a scanning of the container, or is it an interface with the Linux kernel that allows you to view into into the environment that the container is holding?
Yeah, great question there. It's really a non-blocking read that sits on top of the kernel, and we're going to see all the system calls that are going in, and those are placed inside a ring buffer that can be dumped at any point in time when a policy violation happens. So for any of the network people in the audience right now, if you've used something like TCP dump before, it's basically like a TCP dump of your kernel, and it's stored in this SCAP file that then you can go and do deep forensic analysis on outside of production.
Okay, so you know how the services are architected. How do you know the services are architected? What is it that you're doing to be able to determine how the services are architected?
Yeah, so our agent is going to go and start pulling all the different APIs. So the Kubernetes deployment API, the namespace API, and then take that metadata back and use that to enrich all the agents and the data that we're collecting from every physical host in your infrastructure. And then we would go back and look at things at like C groups and namespaces, and then use a kernel facility called tracepoints to get that deep container introspection as well.
So you can see the namespaces, for example. Okay, so how would you say that's illustrated in Sysdig Secure and what we're seeing here now?
Yeah, so let's go and look at this violation that happened in this WordPress container, for example. And I can click into this, and we'll be able to see the full scoping of where this happened in my logical infrastructure. So which Kubernetes namespace, which deployment, which pod, as well as that physical infrastructure. So the container, the image, my host, my MAC address. And then from here, go down further and actually see the individual command output of what happened that triggered that policy violation.
Okay. Yeah.
Yeah, and then from here, you can even go another step further and look at something like the commands that a user executed. So right now, you can go and see, all right, this user ran a shell, and then they ran a curl command to pull down a URL, and then you'll get the full details of this actual URL that they pulled down. So if we look at this closely, pretty sketchy. Looks like they pulled down a rootkit. And then you can see things like the working directory, the host address, and all those kind of things.
So this can be pulled from any registry, really, and it kind of speaks to even if you're using a public registry that may not be fully secured, it can detect kind of the issues that might be surfacing.
Yeah, and we're really just looking for fundamentally malicious activity from your users or from the programs and processes that are running. And so looking for things like writes below a binary directory, shells in a container, unexpected outbound connections from data sources, things like that.
What are you starting to notice in them as containers gain more popularity? One thing I've always been told is the malicious activity begins when when a technology really becomes much more mainstream, right? Then there's a larger impact and potential there. What are some of the patterns that you're starting to see with in terms of security issues in containers?
So I think people a lot of times at the beginning like to focus on the issues. So one of the things that's been really positive about this whole movement is containers kind of offer an opportunity for better security. So they're easier to baseline. They have a single process that's running inside. They also are a smaller attack surface. They're ephemeral, so if some issue happens, you can kill them. So that's kind of one aspect. On the security side, the big thing that people are really facing is that visibility. So since it's not running on a VM, you can't use the existing tools. And containers are essentially meant to be black boxes to execute your code. So going and seeing actually what's running inside them is a real challenge that people are facing. And then also, since they're ephemeral, one of the things that makes them great also makes it really hard to kind of do analysis on something that's probably not even running anymore.
Okay, so what else can we look at here?
Yeah, so we can kind of follow up with this a little bit more. So we saw that URL was pulled down, and then that they used tar to unzip that rootkit. So we can actually go a step further and look at the capture and see that log of all the data that happened around that security violation. So I can open that up with Sysdig Inspect, which is an open source tool that we have for really deep troubleshooting and forensics, and start overlaying activity. So what I've got here is the capture file of every single system call that happened at that point in time when the violation happened, and then I can start correlating pieces of activity. So the violation happened here. We know that user executed a couple commands, and so I can go isolate, okay, the 2 seconds around that, and then start overlaying different pieces of information to try and spot trends. But since we already know that the user did some malicious activity, I can actually go and drill inside here, see, okay, these are the same commands we were looking at before. So we've got that tar command that unzipped that rootkit, and now I can go in and actually do a step further and analyze what happened when that user ran tar. So I can click over here onto files, and what I've done now is I'm looking at every single file that was installed when that rootkit was unzipped on my machine. And then we can go another step further and actually go inside that file and see the individual contents that were written.
Well, you can really drill down.
Yeah, and the beauty of this is we're going to capture all this data, even if your containers are long gone. And it's kind of a workflow where you can start from, okay, hey, some user ran a shell in a container, to, all right, they installed the rootkit, and now I can see the install script that they actually are able to now execute as a backdoor.
So we're starting to see tens of thousands, companies are starting to use tens of thousands of containers, hundreds of thousands of containers, even starting to see some examples of, even more than that, millions of containers, right? How does this act at scale? And so you can be kind of like being able to efficiently, manage all these containers if you are scaling them out.
Yeah, so I think that's where a lot of the orchestrators come in, and then that's going to make rolling out deployments, managing them across multiple hosts a whole lot easier. On our side, we have customers that are running thousands of nodes with hundreds of containers per node, and architecturally, that's where it's awesome to have a Cassandra backend, where you're not worrying about using some type of time series database for your metric store and things like that. And we can really horizontally scale that with the infrastructure that we're managing.
So you recommend a Cassandra database, you said? You said a Cassandra data store.
Architecture, but for anyone their own that they're doing it.
Okay, that's how you're using it.
Yeah.
That's your environment. And why'd you choose Cassandra?
We chose that because at the time some of the other time series databases weren't
what you needed
as robust. And then the way that our data model works, and since we're enriching all the metrics that we collect with all this orchestration metadata, we needed something that would be really flexible and allow you to do the type of dynamic grouping and changing that I showed before in Sysdig Secure.
Okay, great. What else do you want to show here?
That's about it that I had planned for today.
Okay, cool. So what is the next evolution of Sysdig Secure? What are some of those? Well, before I get to that question, what are some of the use cases you're starting to see emerge?
Yeah, so we're seeing a lot of use cases now around doing kind of incident response, especially in Europe around GDPR. So one of the things on the forensic
Help people
side
understand what GDPR is if they're not familiar.
So GDPR is a new data protection regulation that's coming out of Europe where you have to handle PII data in a much more secure way than you did before. And one of the main aspects is if any breach occurs, you have 72 hours to notify authorities, say everyone who's affected, have a mediation plan, all this kind of stuff. So that goes for any company that is handling any type of European PII data. And customers are really loving the forensics and the ability to actually drill down and see every file that was accessed and all that kind of information really quickly. And then the other really big use case we're just seeing is since we're looking for fundamentally malicious behaviors, discovering things that developers were doing or that were going on in their system that they didn't know about before. So that's kind of another place where we really differentiate is a lot of other security tools are working off a list of known CVEs. So they're not really going to spot activity or things like that that shouldn't be happening. It's just going to say, is this package vulnerable or something like that.
Okay. Okay. So what's the next evolution of that we're starting to see in the market, which might we see, which we could potentially see reflected in Sysdig Secure? What are some of those edge cases that we're starting to see that are going to become much more important to address?
Yeah, I think one of the main things is as the container market matures, there's going to be much more data about doing things with containers, and we personally are collecting data from those millions of containers. So being able to automatically recognize, hey, you're running a Redis image. This is what 40,000 other Redis images are doing in production environments, and kind of establishing baselines around how specific images should be performing, and then spotting anomalies against that.
Is there any added complexity as we start to see more stateful environments be integrated into these container infrastructures? Where, for example, we're starting to see we're seeing the container ecosystem community really mature quite a bit. We're starting to see more need for better storage interfaces. For example, we have CSI and we have CNI, the container network interface and container storage interface. Is there, how is that going to affect, the way that we think about runtime security and forensics?
Yeah, so with the stateful services, the way we collect data is going to be pretty much the same, but the things that you're going to be looking for might be a little different. So looking for things like SQL injection attacks, where before if you're running a load balancer, that's not something you have to worry about. So looking for things like the database is spawning a process other than itself, or things like that. And then with the stateful services, one of the things is we'll run our agent as a process as well as a container. So if you have a stateful service that's interacting with your containers outside, we'll be able to monitor both of those.
Great. Well, Knox, thank you so much for taking some time to talk about Sysdig Secure. We look forward to keeping in touch with you about it. And are you going to be at KubeCon?
Yep, we're going to be at KubeCon, reInvent, pretty much hitting the trade show circuit hard to end the year.
Okay, well, we'll see you. I'll be at both of those conferences, so hope to see you there.
All right, thank you.
Thanks, Knox.
All right, thanks.